Hello my dear friends, today we shall continue the topic of the Laplace transform. In the last lecture we have just introduced the notion of Laplace transform. We have defined the Laplace transform. After that we have found the Laplace transform of some elementary functions. Laplace was the French mathematician. He was astronomer also. He was known as the Newton of France. So, this is widely used in the solving the variety of differential equations. Yeah, it has very cracking applications in the engineering field. So, let me click the refresh button at the outset. What is the Laplace transform of some function, say f of t? If this is the function given to us, which is a piecewise continuous from Tn onwards, then what do we mean by the Laplace transform of this f of t? Just multiply this function f of t by e raised to power minus st. Okay. Multiplying the function f of t by e raised to power minus st. Then integrating this product between the limits 0 to infinity with respect to t. This value of definite integral of from 0 to infinity of e raised to power minus st into f of t, that becomes the function of parameter s. This is denoted by, say, f of s. It contains, and it is called as the Laplace transform of f of t. So, whenever we want to find the Laplace transform of any arbitrary function, you have to follow two steps. At the first step, foremost step, multiply that function by e raised to power minus st. Then integrate the product with respect to t between the limits 0 to infinity. Evaluate the integral. Whatever answer comes, that is the final Laplace transform of that function. We have found the Laplace transform of 1. Laplace transform of 1. It is function of t. It can be considered as t raised to power 0. So Laplace transform of 1 is 1 by s. We have already seen in the last lecture. Laplace transform of constant k is k by s. Laplace transform of e raised to power plus at is equal to 1 upon s minus a. Laplace transform of e raised to power minus at is obviously equal to 1 upon s plus a. Laplace transform of a raised to power t is equal to 1 upon s minus log of a. Laplace transform of sin h of at is equal to a upon s square minus a square. Laplace transform of cos h of at is equal to s upon s square minus a square. Laplace transform of sine of at is equal to a upon s square plus a square. Whereas Laplace transform of cos of at is equal to s upon s square plus a square. A very little difference between these hyperbolics, Laplace transform and transform of the trigonometric functions. After that, we have also seen that Laplace transform of e raised to power n. If n is fraction, then it is equal to gamma of n plus 1 upon s to the power n plus 1. If n is purely an integer, then the Laplace transform of the same function t to the power n. Gamma of n plus 1 is equal to factorial of n upon s to the power n plus 1. So that is what just we have seen this in the last lecture. Laplace transform of this. These are supposed to be the elementary functions. With the help of this, we shall develop the idea of finding out the Laplace transform of some variety of some more functions. So let us examples. Obtain L.T.of number 1, 3 e raised to power minus 2t minus 5 e raised to power 6t plus 2. The function whose Laplace transform is to be obtained is function of t. So that is denoted by f of t. So f of t is 3 times e raised to power minus 2t minus 5 times e raised to power 6t plus 2. Now I will take the Laplace transform of both sides. Therefore, Laplace transform of f of t is equal to Laplace transform of 3 times e raised to power t, that is equal to 3 times Laplace transform of e raised to power minus 2t minus 5 times Laplace transform of e raised to power 6t plus Laplace transform of 2. All these 3 functions, they are standardized. Whose standardized means whose Laplace transform you already know. So this is equal to 3. Now Laplace transform of e raised to power minus 2t is 1 upon s plus 2. Because Laplace transform of e raised to power minus 8t is 1 upon s plus a. Minus 5 times s minus 6. Laplace transform of e raised to power 80, 1 upon s minus a plus 2 over s, 2 by s. Laplace transform of constant k is k by s. So Laplace transform of 2 is 2 by s. So that is how we obtain the Laplace transform of the first example. Second, f of t is equal to p minus 2 whole square minus root 3 by 7 plus 2 raised to power t minus cos h of 3. Very simple. Now t minus 2 whole square means it is t square minus 4t plus 4 minus root 3 by 7 plus 2 raised to power t minus. Now what is cos h of 3t? It is half of e raised to power 3t plus e raised to power minus 3t. Exponential formula for cos h of at is half of e raised to power at plus e raised to power minus at. So dissolving this into standardized functions, so this is equal. Now, Laplace transform of t square. It is t to the power n. Here 2 means it is an integer, so it is equal to 2 factorial upon s cube. Laplace transform of t raised to power n is n factorial upon s to the power n plus 1. I have used just that formula. Minus 4 times. Laplace transform of t is 1 by s. 1 factorial upon. Laplace transform of 4 is 4 by s. Sorry, minus root 3 by 7. Laplace transform of root 3 by 7 is root 3 by 7 divided by s. Minus half of. Laplace transform of e raised to power 3t is 1 upon s minus 3 plus 1 upon s plus 3. That is how we determine the Laplace transform of some elementary functions. Now, we shall take on some more examples. Now let us determine the Laplace transform of some trigonometric functions. So before taking on the wide variety of trigonometric functions, let us recall some basic formulae of trigonometric functions. Important formulae. Note this. You must know this. Number 1. Sine square of t is half of 1 minus cos of 2t. Second, cos square of t is half of 1 plus cos of 2t. Sine cube of t is 1 by 4 times 3 sine t minus sine of 3t. Fourth one, cos cube of t 1 by 4 times 3 cos t plus cos of 3t. And 4 important major sum and difference formulae, they are 5. Sin A into cos B is equal to 1 by 2 times sin of A plus B plus sin of A minus B. Sixth, cos A cos B is equal to 1 by 2 times cos of A plus B plus cos of A minus B. Sin A sin B is 1 by 2 times cos of A minus B minus cos of A plus B. Should note this formula. These are fundamental formulas, trigonometric formulas. Now, subject to this, we shall found the Laplace transform of some more functions. Example number 3. Laplace transform of sine square of 3t. We don't have the formula of Laplace transform of sine square function. Perhaps we can deduce this sine square function into some linear function in trigonometric form. So, sine square of 3t can be written as 1 by 2 times 1 minus cos of 6t. Sine square 3t is half of 1 minus cos 6t. Now, this has now been completely standardized by virtue of this formula. Now, taking the Laplace transform of this, therefore, this is equal to 1 by 2 times. Laplace transform of 1 is 1 over s, 1 by s minus. Laplace transform of cos 6t is s upon s square plus 36. So that is Laplace transform of sine square 3t. Now, fourth one. Laplace transform of cos square of say 5t. Again, we cannot directly find the Laplace transform of, there is no formula for Laplace transform of cos square function. Perhaps we can express cos square of 5t as Laplace transform of. Expressing cos square 5t as 1 by 2 times half of 1 plus cos 10t. Whose Laplace transform we know? That is equal to half of Laplace transform of 1 by s. Laplace transform of cos 10t is s upon s square plus a square. A is 10 over here. 10 square is 100. So, let us compute Laplace transform of some more functions. Five. Laplace transform of sine cube of 4t. That is equal to Laplace transform of 1 by 4 times sine cube of 4t is equal to 1 by 4 times 3 sine 4t minus sine of 3 times 4t is like 12t. I will just use the formula of sine cube of t is 1 by 4 times 3 sine t minus sine of 3t. Here instead of 3 we do have 4t. So that is further equal to 1 by 4 times 3 into Laplace transform of sine of 4t. A is 4. So it is a upon s square plus a square. So it is 4 upon s square plus 4 square minus sine 12t. It is square upon s square plus square of 12, 144. That is the Laplace transform of sine cube of 4t. 6. Obtain the Laplace transform of cos cube of 7t. Cos cube of 7t can be expressed trigonometrically as 1 by 4 times 3 cos t is 70 plus cos of 21t. That is further equal to 1 by 4 times 3 times Laplace transform of cos of 7t is 7 times t is s upon s square plus square of 7, 49, plus cos of 21, it is s upon s square plus 21 whole square, it is 441. Seventh, Laplace transform of sine raised to power 4 of 2t. We can employ the same formula for this. How? We don't have formula for sine raised to power 4 t. Perhaps this can be expressed as Laplace transform of sine square of 2t whole square. Sine raised to power 4 2t is square of sine square of 2. Again, sine square of 2t, Laplace transform of half of 1 minus cos of 4t whole square. That is further equal to Laplace transform of 1 by 4 times. Now I am squaring this bracket. Square of this bracket is square of 1 minus 2 times cos of 4t plus cos square of 4t. Now check. By employing formula, this has been completely standardized or not? Standardized means whose Laplace transform we know. This is not standardized, square function. So, cos square of 4t can be expressed as, once again I would be write the same as 1 minus cos of 4t plus cos square of 4t is equal to 1 by 2 times in bracket 1 plus cos of 8 times t. Inner bracket close, outer bracket close, and so on. Now, we observe over here the given function sine raised to power 4 of 2t has been completely standardized. Now, taking the Laplace form, that is equal to, I am taking the Laplace transform 1 by 4 times this square bracket Laplace transform of 1 by s minus Laplace transform of cos of 4t is s upon s square plus 4 square plus 1 by 2 times Laplace transform of 1 again 1 by s plus Laplace transform of cos of 8t is s upon s square plus 8 square, inner bracket close, outer bracket close. So that is nothing but the Laplace transform of sine raised to power 4 of 2t. Eighth example, obtain Laplace transform of cos raised to power 4 of 3t. Again the same funda I am using as I have used in the previous example. Laplace transform of, it is square of cos square of 3. Square means raised to power 4. The function is cos raised to power 4 means square of cos square of 3t. Now what is cos square of 3t? Half of 1 plus cos of 6t whole square. That is further equal. Now I will square this bracket. Laplace transform of 1 by 4 times 1 plus 2 times cos of 6t plus cos square of 6t. Again expressing this cos square of 6t, Laplace transform of 1 by 4 times 1 plus 2 cos 6t plus cos square of 6t, half of 1 plus cos of 12t. I am using the formula again. Now it has been boiled down to the completely standardized form. So taking the Laplace transform here at this step is equal to 1 by 4 times 1 over s Laplace transform of 2 times cos of t 60. 2 times Laplace transform of cos 60 is s upon s square plus 36 plus half of Laplace transform of 1 by s, and that is of s upon s square plus 144 . Similarly, we can find the Laplace transform of some higher powers also. Next example. Obtain Laplace transform of sine of 2t plus 3. How to find out this? What is sine of a plus b? Use that formula over here. What is sine of a plus b? Sine of a plus b. Here a is 2t, b is 3. So it is sine 2t into cos of 3 plus cos of 2t into sine of 3. Sine of 2t plus 3. Now taking the Laplace transform. Here cos of 3 is constant. In the second term, sine of 3 is supposed to be constant. So cos of 3 into Laplace transform of cos sine of 2t. It is 2 upon s square plus 4 plus sine of 3 into Laplace transform of cos of 2t. It is s upon s square plus 4. Similarly, sine of 5t minus 3. What is Laplace transform of cos of 3t minus 5? That is equal to Laplace transform of cos of 3t minus 5 is equal to cos 3t into cos 5 plus sine 3t into sine 5. Completely standardized using the formula of cos of a minus b, cos a cos b plus sine a sine b. Now taking the Laplace transform. Here cos of 5 is constant and sine of 5 here is constant. So cos of 5 constant times Laplace transform of cos of 3t is s upon s square plus 9 plus sine of 5 times Laplace transform of sine of 3t is a upon, here a is 3, b upon s square plus 9. That is how we determine the Laplace transform of such type variety of functions. So I hope you have now got the enough knowledge and some practice and consideration of the Laplace transform. Thank you very much. Thank you.